Okay, no issue.
Good afternoon, and I welcome everyone here for our last day of this ATAL FDP program, session 11. Now, I'd like to give a brief introduction of our esteemed speaker of today's session, Mr. J. Srinivas Venkat Sir, Solution Architect, LSG, Nottingham, England, UK, with an years of experience, 19 years. Sir has almost like 2 decades of cross-industry experience and combines technical expertise with practical solution design skills to deliver robust data-driven architects, and background covers end-to-end integration of high-volume databases and ETL platforms by strong knowledge of cloud data warehouses and enterprise integration tools. He completed his bachelor's degree in computer science and engineering in Bangalore University. He worked as an associate in Catty Logistics, and thereby he worked as a developer in ITC Infotech India Private Limited and ETL developer India ITC Infotech Private Limited. And he worked as a team lead in Oracle and ETL consultant in ITC Infotech Limited. And thereby he was an data warehouse consultant in Deloitte Consulting for the client Aveva Life Insurance Company. Later, he moved to London Stock Exchange Group, LCH Swap Clear, with as a senior data warehouse consultant and data architect. Then, as a team lead role of the solution architect and data architect manager in the London Stock Exchange Group with corporate technology. And presently, he is working in Cognizant Technology Solutions, Snowflake Solutions Architect, Data Engineer. It's an honor to have you, sir. And now it's a privilege to invite our session speaker, Mr. J. Srinivas Venkatesar to deliver his presciential knowledge and guide us with his vision for faculty development and research on topic tools and technologies for AI-powered cyber threat intelligence with the framework of data security. Sir, please start the session, sir.
Thank you, Uma. Thank you. Hello, everyone. So I'll just give it is a topic on data security frameworks, but it's loosely related to the cyber technology. I'll cover the Gen AI and all of that stuff towards the end. Yeah, on that note, let me quickly share my screen. I'll switch off my camera and then I'll quickly share my screen with you. Just give me a minute, please.
Srinivas Venkatesar, sir, you can share your document. We are unable to hear your voice.
Can you hear me okay, Prasad, now? Can you hear me okay?
Now it is okay. You are visible and your voice is audible.
Okay, perfect. Just give me a moment, I'll just share my presentation.
The Srinivas Venkat, you can share the document. You have been given co-host permission.
So your voice is not audible. Srinivas sir, can you hear me?
I can hear you. Can you hear me?
Yeah.
Is it better now?
Yeah, it's good. It's good now.
Okay. Just a
Okay.
moment. All right. Do you want me to start, or is it okay if I continue from here? Okay. All right. I'll just continue from where I am. So, a quick background about myself. So who I am, and then what I do, and then what I work on. I mean, because this topic is related to data security frameworks, I'll just give you a quick. I'll walk you through an incident that happened during early years of my career when I started working in one of a big financial organization. So during when I was working in a big financial organization, I think there was that was I was relatively new. This is back 15 years back. So it's a big investment banking firm, and basically there was a huge and we embarked upon a big migration exercise. So I think the business that the company I used to work for is investment banking. They used to clear swaps, but the swaps of financial instruments, and then the company that I used to work for used to act as a central counterparty, i.e., it used to manage the risk between two counterparties. So basically, one guy books the trade, and then other guy buys the trade. So basically, after during as part of that migration exercise, I think there was noticed. I think there's people moving around and then wondering what to do. Um, so I basically we did our work, and then I think clearly that states that the migration didn't go well. So there was a lot of people going around on the management operations flows, and then trying to figure out what exactly had happened. So basically, one of the deployment, I think that was one of the key critical moment. I think so the deployment went wrong, and then basically we shared the data that was intended to a particular customer with the other customer. Basically, that wasn't supposed to happen. So effectively, there is a breach. There is a breach because we distributed the data to positions data to a customer who isn't supposed to have access to it. So all the senior management was around, and everybody were trying to figure out what needs to be done. So effectively, so the organization is very good at managing risk, and then they have a very good data security framework in place. So they exactly knew what they need to do, and then how to actually remediate it. So I think that was an eye opener for me, and I think I kind of realized that how important. I think it's not just delivering technology. I think it's also important to manage data security, governance, and everything. I think whenever you work on a project, I think you always needs to go to the compliance team or the architecture team, and then ask them, okay, what are the data security controls that we need to follow, and then try to embed all of that in the delivery that you do. So it was a big learning for me at that point. I think so. Whenever I do any project, I think this first thing that I do is I ensure that I instill those principles in the delivery that I embark upon. On that note, I just wanted to give a quick intro of myself. So I think by the time I think you have an idea of what I do. So I work as a solution architect in one of the leading financial services. predominantly work on enterprise data and the cloud data warehouses. I think because data is key for any financial organization. I think that is huge data, and people want to democratize that data. Historically, all that data used to be on-prem, logged in with tight controls, and then people never basically never realize that they are sitting on top of a gold mine, and basically, but to unlock that potential, I think they had to move that data to a cloud and then use the unlimited compute, so which can scale infinitely in cloud, and then unlock all of the potential insights that their organization data can provide. So so predominantly, I think my work for the last 5 to 10 years is working on the cloud and then moving customer data into cloud, and then off late, I think because of the advent of the OpenAI and Gen AI and a lot of other stuff, and now a lot of people are integrating all of their systems, and then basically they're realizing the value of the data using all of the Gen AI and agentic AI, which have become very popular now. So I worked across various domains. So basically, across most of the time around investment banking and financial and insurance, and some retail as well. Lived here in UK for the last 22 years, and then I still live here in a city called Nottingham. I think people can correlate that place with Trent Bridge. I think most of the cricket matches happen over there. Yeah, that's about me. I think let's jump into our main topic. Right. Cool. So I can't see the chat, but so how many people are aware of how do you define a framework? Can somebody gives a thumbs up and then just say whether they know what the framework is, just to make this interactive. Okay. All right. Okay. Yeah. So I don't want people to get bored. So I just wanted to have that interactive session and hence I ask a question. But yeah, that's okay. I'll just move on. So how do you define a framework? So a framework, I think if you see the picture on the slide towards the left, basically it's a foundation. It's a foundation that you can use to build something on top of it. So it can be anything actually. I think you can apply that analogy to anything that you do in a normal life. So basically, it can be a software, it can be an industry, it can be a factory, it can be a house, it can be anything actually. So basically, it's a foundation, and what framework gives you is tools and then rules, and a structure for you to actually use those principles to build upon, and then succeed in that whatever project that you do. So how do you define, how do you explain framework to a layman? So in simple terms, basically, as I mentioned earlier, so it's a ready-made structure or a foundation. For example, if you're building a house, so I think you already know to build a house that you need to dig a foundation, you need to put some concrete, you need to build the structure, steel, and everything. And basically, these are all standard. I think these are all the things that are available already. So, uh, so, so, so basically, you apply those rules, those principles, and then you build your foundation, and then whatever that you could do on top of it is up to you. How do you customize it? You can decorate it in multiple ways. You can have a number of rooms, and then you can have once you build on top of that foundation, your house stays strong, and then however you want to decorate it, I think that's up to you. So So this is an analogy that I'm taking just to better explain what a framework does and how important it is when you apply in real life, either in software or any industry. So it's not just limited to the software industry. I think this applies to anything, and each and every industry have got their own frameworks defined. So why use a framework? Why? So basically, it saves a lot of time. So you don't need to reinvent the wheel and then go back and say, okay, let me figure out how deep I need to dig a foundation for my house to stay strong. So if you're building 10 floors, you need to dig a foundation at a certain level, and then you need to the width of the column should be a certain size with a certain strength. So you don't need to do that. Actually, those foundations are already available, so you don't need to reinvent it. I think it's already available for you to actually use that knowledge and then build on top of it. If you apply that to so in IT and IT world, so it makes your code cleaner, more secure, and then it's easier to maintain if you follow those frameworks. Not just performance, it can be security, it can be logging, it can be anything. So it makes your life easier, and then it makes the support staff can easily maintain that code if you follow all of those foundations and the frameworks that an organization mandates you to follow. And it takes away all the complexity. So you don't need to worry about actually how deep do you need to dig or how complex you need to write. So basically you can concentrate on what needs to be delivered in a project. So it takes away all of that work. I think if there are patterns that are available as part of that framework, you can just directly pick up those patterns and implement it. It can be programming, it can be anything, it can be deployment, it can be it applies to anything that you build. So I hope everybody is okay. Let's move on to any questions. Cool. That doesn't know. Right. So what exactly are data security frameworks? So how do you actually define it? So basically security frameworks. Basically, these are a structured set of guidelines and policies that are designed for an organization to follow to protect the key assets. So the assets can be data, they can be systems, they can be it can be any asset within an organization. It can be a simple like an entry into an organization. So it can be anything. It's not just this. So basically, what it does is that it avoids all of the unauthorized access, breaches, loss, and corruption. So if an organization has got a compliant data security framework, then basically it can avoid a lot of risks that are currently well, posed by the threat actors in the market. So what does it do? So basically, it has a data security framework. It's a detailed, comprehensive approach to cover all the necessary processes needed to protect the sensitive information, and then and also be compliant with the laws of the land. So yeah, so I think to protect customer data, I think governments mandate you to implement a certain set of regulations, and if at all, if you don't follow them, they can be consequences, which we'll cover later in the slide. Cool. So I think before I go on to the next slide, I just wanted to give you key components of what data security framework has. So basically, you have policies and procedures. data classification, access control, risk management, incident response, compliance, and then training and awareness. So there are a number of components that are part of our data security framework. I think the reason I'm covering these is basically these are the pillars for any data security framework that's available in the market right now. So you can take any standard security framework, but all of them are actually based on these key components. You take any framework, but basically it can evolve over time. I think with the changing times, basically this can evolve and this can change, and more policies and procedures. But the key components are going to remain the same, but the way that they get implemented might change. Okay. Okay. So let's take a step back and then say, okay, what happens if you don't follow data security frameworks or controls? If an organization, or it can be anything, I think it can be your education institution itself. What happens if you don't follow? So I think there can be consequences, right? So basically, data security frameworks allow organizations to systematically secure their data and then reduce the risk of breach or any compliance with the laws of the land, and also provide trust to your customers and then regulators that you manage data responsibly. So without implementing these frameworks, I think there are a lot of risks. I think you can get fined. There can be a number of consequences, or there can be risk to life as well, because you're leaking the information, or somebody steals information, your customer information, and then various things can happen due to that. So let's take a real world example of sorry. Sorry, my PowerPoint closed. Let me reopen it. Sorry. Can you see my screen now? Yes, no? Can somebody see my screen? My PowerPoint just crashed. I just restarted it. Hello? All right. Okay. Right. So coming back to the topic again. So what happens if you don't submit? So there will be, I think if you have an open, or if you don't deploy enough controls on the data that you manage, I think there can be a number of attacks by threat actors. So they can breach your systems, and potentially they might be basically the way that you function may affect. So that can lead to loss of revenue, and then a lot of legal actions, and then probably customers can lose trust. And then the bigger thing is that it's interrupted operations. You can't carry on with whatever the business that you're doing, and then that can lead to financial loss as well. So let's take a real world example where something of this sort happened. So recently, I think most of the people would have read this in the news. So there was a big supermarket giant called M&S in UK. Basically, there has been a cyber attack. So I think there's a disclaimer over here. What I'm saying is that MNS is a very reputed organization. I'm not saying or implying that they don't deploy any of this, but out of this is a thing that has happened over there, in spite of all the key controls that they've deployed. So effectively, I just want to bring this up because this has happened, and then and there have been some lessons that that they've learned basically as part of the systems breach. So which I'll cover towards the end of the slide, but I just wanted to walk you through exactly what happened with that this thing. So there has been a cyber attack. So attackers used social engineering. I know most of you know what social engineering is. Basically, it can be various forms. I think the easiest one is a threat actor can actually can identify your email from a social media or LinkedIn or Instagram or anywhere. Basically, if you just say you work in such and so place, they might contact you and then say they might offer you a job or whatever it is, and then they ask you for your email ID, official email ID, and then what they do is that they just send out an email which looks very identical to a legitimate email, posing as a seller or a vendor or a partner or whatever it is, and then basically he might inject some kind of a code that can infiltrate, and then basically it can compromise your systems. All right. Just a moment, please. I can see somebody in the chat pinging. All right. Okay. So the threat actor used social engineering to gain access to network access to the infrastructure. And basically after that, what they did was they kind of went into the network, identified, they exfiltrated the Windows domain controller, and then took the NTDTS file, and then which contains the hash passwords, and they kind of cracked it offline, and then they did a lateral movement, i.e., when it's a lateral movement, to the using admin tools available within the environment. I think they gained access to the network infrastructure, and then they deployed the ransomware. They deployed the payload, and then basically that's when everything went loose. So basically, all I'm saying is that they did some kind of a social engineering to gain access, and then, but the consequences are big, right? So because of this, I think there's a complete disruption. Their online their online shop, everything went down, and then basically their CRM and ERP, and basically all the systems were compromised, and then people, they couldn't deliver the right amount of stock to the right stores, and then people are not able to log in. Basically, it's a big damage to the whole operations of MNS. So it's a cascade. So basically, they had to fight many things at one time. So and the key thing is that, and there was a risk of personal data exposure as well, which is a big breach, because that attracts a lot of penalties from the government. It's estimated that MNS would have lost around 300 million in revenue as part of this disruption. And then more than that, I think it's the personal data of the customers, like names, date of birth, addresses, phone numbers, their purchase history. Yeah, they couldn't get the card details, but again, basically all of this data has been compromised. So many systems were offline. It's a big thing. I think it took quite a while for them to actually identify and fix the issue. But again, basically, because of the breach, they did have to. There's major disruption to their operations. Right. I think the reason I brought up this is just to highlight how important data security frameworks in any organization is. But let's revisit this towards the end of this presentation, and then I'll see what are the key takeaways. So I just wanted to bring out this example. There are many examples. I think there is a data breach at Sony where people basically stole all of the customer data. So there are a number of examples. I think you can Google it. I think people you would find a lot of instances of these. That doesn't necessarily mean that the people or organizations are not following the data security frameworks or any security or any cyber threat frameworks or anything like that. I think it just highlights that people are getting smarter. They have new tools available to infiltrate or breach systems, well-protected systems. Yeah. So this is where I think the Gen AI and agentic AI can actually help and then learn and then evolve when you actually deploy all of this frameworks systematically. So any questions? I think I've been blabbering for almost 30 minutes. If you have any questions, please give me a shout, or else let me continue. Right. So as I mentioned earlier, that there are a number of key components for the data security framework. So I think these are the basis, or they are the kind of foundations or the pillars for any of the framework or any standard, any standards that are being defined or available in the industry. So again, key components, data classification, inventory. I'll go one by one when we go through the slides, but I'll just run through each one of them. So you have access control and identity management. You should have a strong encryption. You need to have security policies and procedures. And then it's not just you need to have them, you need to enforce them as well. It's not good enough to have security policies and procedures. You need to mandate to your people to actually use them. Yeah, so define who's responsible for which data. So any organization, I think, I think this is a fundamental thing. I think you need to have ownership for the data that is being managed. So, for example, it's a HR data. So somebody at a head of kind of level should actually own that data, and then basically he has to mandate how that data is shared, used, and processed. So you need to have a rigorous risk assessment and management controls, and then you need to have a plan how to mitigate those risks. So you need to have effective monitoring, detection, and response, backup and recovery, compliance and audit, and security training and awareness. So let me go through each one of these in the following slides. Something I did mix. Yeah. Yeah. So these are all the foundations of data security. So somebody is pinging anything. Right. Okay. Cool. I hope I hope it's not boring. I think I don't have any live demo to show you, but this is what it is. I think always if you talk about a framework or anything like that, I think it's always boring for people to follow. Right. Okay. Any questions before I move on? Are we good? Cool. Okay, I'll take that as an S. Let's move on. Right. I think in the previous slide, I showed you the key components of the data security framework. So I think I'll just go through one by one and then talk you through what they are. So it's not in a particular order. It's just a random order. I just picked up and then put them and then summarize them. So didn't take me to it. So the first one is the data classification. Yeah. So how does data classification helps us uh, in deploying the secure data security framework? So basically, it control data classification systematically. Well, these controls. If you can categorize your data based on their sensitivity and importance and risk, then it gives you a better understanding of how to manage that. So, for example, if you're managing petabytes of data, either in a database, on-prem, or disk, or anywhere, basically, if you can't classify it, you don't know what is the risk exposure of that particular data set. So always classify your data. You define what data classification what categories that your organization needs to have. So not all organizations should have a similar categories, but usually I think they're defined as uh, well, corporate being is internal, and then there's a public information, for example, reference data. So an example of reference data in a financial institution can be exchange rates, or it can be ticker information or something like that, which is freely available in the market. And anything sensitive and highly sensitive data, highly restricted or highly restricted data. So, and then you define what are the controls that you need to apply for each of those categories. So when you say highly sensitive data, then you need to define a process to protect that particular data. When you say, then again, it comes, okay, access control. So it's all interrelated. So data classifications would give you a good understanding of how to protect that data and then how to manage that risk. So again, as mentioned, your data can be categorized as public, internal, confidential, restricted, highly restricted, and it's PII data as well, which is highly restricted data. It's personally identifiable information. Yeah, sorry. So I think it's categorizing is one part of it, but it can't act alone. So you need to have something else. So you need to follow the other principles or other pillars of the framework. So this is a pillar that can actually help you to actually see or target your resources of which data to protect. So as I mentioned, if you have a petabyte of data, you don't want to just encrypt everything, or you just want to block everything off so that nobody can have access, because it's a no-brainer. It doesn't help anyone, because that takes away a lot of your resources, your time to manage it. So yeah, so again, once you classify data, then you can apply appropriate access controls. Right. Okay. So I think I just covered some of these already. So if you classify data, you can do efficient resource allocation. You can focus more on what data that needs to be protected, what critical assets that needs to be protected. So you can spread your effort on those rather than actually just wasting time in actually implementing controls on the data that you don't really need to worry about. So the other thing is that I think it is a good it is a good measure, i.e., from a regulatory perspective. I think you can always say, okay, this is highly sensitive data, and then we are adhering to a GDPR or HIPAA or whatever it is, other regulations that the law of the land stipulates. So, and the data classification also allows you to better manage risk, which we've already covered, but there's a separate slide for that, how we can manage risk. So basically you can prioritize assets, and then you can protect them, and then if something happens to that particular data, what are the steps that you need to follow, or the response that you need to adhere to in case if there's a breach of that particular sensitive data. So enhanced data lifecycle management, again, this is another pillar which we're going to cover later. But again, classification also helps in actually deciding which data that you need to back up frequently, and then and how long do you need to retain it. I think there are, and again, this ties back to your regulatory compliance, where you're supposed to hold financial transaction data. I think in UK it's around 7 years, I believe. So even though you're not using it, you just need to hold that data somewhere, and then whenever regulators ask you, you just need to provide that data to them. Moving on, encryption. I think this is my favorite topic. I think so. Encryption in any software project is key. So basically, sorry. Yeah, I think moving back onto that, I think this funnel gives you an indication of how you need to categorize it. And I mean, as I mentioned, your most protected data sits at the top, because it might be a small amount of data that so you don't need to protect your whole organization or all the data that you have in your organization. Okay. Oh, yeah, coming back to encryption. Right, encryption is key in software development. I think now, since the workloads are moving into cloud, I think encryption is a vital part of any deployment that you see anywhere. For example, I don't know how many of you are aware of workloads in cloud like AWS, Azure, GCP, and a lot of SaaS platforms that are available. I think if you look at that, even the tools that they provide you to access those applications programmatically, like the JDKs or the drivers or the .NET drivers or the JDBC, ODBC, anything that you integrate within your software to access those platforms. I think the first thing that they do is they deploy the encryption. So when I say encryption, it's not. So encryption can be two types. So like how do you deploy encryption, where data is at rest and then data is at transit. So there are two. So there are two ways that you need to apply encryption when the data moves from one place to another. So what is encryption? So again, you would have already studied about it, so I don't want to go there and then talk about encryption again. So basically, it's just converting a plain text into a cipher using cryptographic algorithms, and then you have a key to actually decrypt it, and then you ensure that that's the whole communication or the whole packet is encrypted right from the sender to the receiver. So that's data in transit. But what data at rest is basically any data that you persist on the disk, or any network storage or any storage. In fact, it's just not. It's not just data on the disk or on the server. It can be any storage systems that you use to deploy your workloads. So it can be files, hard drives, databases, backups, anything. So that's data at rest. So ensure that your data is always encrypted. So basically, what does it do? It gives you that extra layer of protection, because if somebody gets access to it, they just can't straight away take that data that's available and then unpack it and then use it. So they need to go through another layer of actually decrypting the data. So if you use a well established cryptographic algorithms with a wide key, then and then if you apply a unique sort to it, basically it makes the threat actors' life difficult to actually decrypt that data, even though they gain access to your system. So that's data at rest. I mean, in an organization, the way that the framework, I think each and every organization, I think the places that I've worked, I think people ask you to encrypt the logs that are generated by your application. So basically, it's not, you're not allowed to leave anything, even the logs that you write onto the disk. So basically, you just need to apply the encryption to everything, so to make sure that it's completely secured and protected. We did talk about data in transit. So basically, if the data moves from point A to point B, ensure that encryption and that transfer mechanism is completely encrypted. Well, again, there are a number of so this is just a high level. I think when you come to the cloud deployment, there are a number of ways where you can protect your data, where you can completely make your data transmission away from the public internet. So there's something called as private connectivity, where all of the cloud service providers have their own dedicated lines where none of the public internet traffic goes. So basically, the data travels between two private endpoints from source to target. So and all of these are available in the frameworks that that we're going to talk about later. Basically, you just need to apply those principles, and if you based on the domain that you work on, and then and basically these are stipulated by your security teams, and then the organization, or basically your leadership mandates you to follow this thing. I think the end goal is resilience. I think resilience is key. And then to do that, to have that, I think you need to follow all of these things. Conscious of time, let's move on quickly. Okay, we talked about data at rest and then data in transit. So data actively moving across networks, also between users and servers or across the internet. So what encryption does, secures that transport layer between two endpoints, and then ensuring that people cannot access, even though they can, if they intercept the packets, I think they won't be able to access, because the key resides with the at the origin or at the receiver end. So examples and protocols, I mean, usually the standard is TLS 1.2. I think nobody uses 1.1 now. I think everybody mandates TLS 1.2, and SSL, secure sockets layer, used for browser communication. And then the other one is the VPN encryption, and the third one is private connectivity. So basically, it takes your traffic completely out of the public internet, and then the traffic flows using the dedicated lines provided by the cloud service providers. Okay. So in summary, so data at rest, what encryption protects signals, so physical theft, unauthorized access to storage, common methods, FDE, full data encryption, and the file and database encryption, data in transit, and how does encryption helps us? It helps us in securing our transmission or the data movement from eavesdropping, interception, or tampering during the transfer. The common methods are SSL, TLS, VPN, and then private connectivity. Okay. All right. Okay. So again, going back to our pillars again, I think we talked about. I'll just run through, conscious of time. I'll just run through quickly all of these slides, and then I'll talk about the frameworks and that standard frameworks that are available in the market. I think I've got 30 minutes to cover. I'll leave 10 minutes for the Q&A. So again, access controls. So there are various kinds of access controls that you can deploy in an organization based on the type of data or the thought process and the vision of your leadership team. I think whatever they want you to whatever they mandate you to deploy in the organization. So there are various kinds of access controls that you can deploy. It's called mandatory access control. It's called MAC. Centralized control with system administrators, and then basically it's usually used in government environments and then requiring high confidentiality. Discretionary access control, DAC, resource owners like have the authority to grant restrict access to others. Basically, there is some level of delegation, but not complete. And the other one is the most famous one is the role-based access control. I think this is what is used in most of the places. So it's called RBAC, where the users are not directly assigned any privileges to anything. What in turn they do is that they define a role. For example, if you're a HR admin or a HR analyst, so what they do is that they define the privileges or the identity access management that's relevant to your particular role, and then assign that role to that particular user. So this offers flexibility because it gives you enough oversight of who accesses what in your organization. And then again, it's a rule-based access control. Access granted according to a set of rules and policies. So I think you can correlate this to IAM policies or identity access management policies, which we'll cover next. So effectively, you mandate the access. For example, if you're accessing a storage bucket, and then you just need to say that, okay, you want that storage bucket to be accessed only from unknown IPs, from your web proxies, or from the IPs of your Citrix Citrix infrastructure where people have their desktops running. And again, the other one is, I think this has been, the other one is the attribute-based access control. Again, this is a fine-grained access control that a lot of people are deploying now. Basically, it actually tells people or any resource, I think, it gives access to only the, it doesn't give the access to complete data. It only gives access to based on the attributes that they're supposed to see, and everything else is obfuscated. The other part of access controls is identity and access management. I'm sure by now, you know, I think, so there are two things. There are two components that form part of our IAM, which is identity access management, authentication and authorization. So authentication is verifying who you are, and then authorization is something, okay, what you can do, or verifying what permissions that you have to conduct your to conduct your work. So basically, these two are the two key components of IAM. And then in the industry, there are a lot of providers that are available, and along not with just to who manages the identity access management. On top of it, they deploy other means to actually secure and ensure that enough security controls are deployed, like strong authentication, and then using personal access tokens or MFAs, just to add that extra layer of security for the people who are accessing their systems. And then you do all of this, and then I think you do need to have a periodic access reviews as well, which we're going to cover as an audit, and that comes up later in the slide. Again, security benefits. I'll just quickly walk through, conscious of time. I think we do have only 20 minutes left. I just want to leave 5 minutes for Q&A at the end. So, right. I think this is key: security policies and procedures as part of data security framework. So basically, you just need to state, why are we defining security policies? Okay, you need to define the purpose and objectives. See, what is the benefit? I think what are you trying to protect by deploying these security policies? So it's not just people in the compliance who actually dictate these, or in the architecture who actually says this. I think that common understanding should be instilled within everybody so that they adhere to it. You need to clearly define scope of what those security policies, where those security policies is applied, to what systems, data, what business units, and who owns it. You need to have backing from your management to deploy all of that, and then they need to effectively communicate those policies on then why do we need them, why they are so important for any organization. You need to clearly assign roles and responsibilities. So again, and then you need to have enough security controls to ensure that these policies are deployed and monitored, so people are using them. So this, just take a general example. You can create all of those laws that you want to have, and then if there is no police to actually implement them, then there's no point. There will be chaos. Similar to that, you define all of these policies, and then you need to have some kind of a team who can actually deploy those policies and then monitor them and then measure them, how they are implemented. So that's access control and authority. Yep. Okay. Okay, so as part of that, again, data classification and handling, I think we need to set out rules. How do we categorize data, which we've already covered. We need to have an operational procedure, best practices of how do you manage various policies that you actually define for backups, people management, securing your servers, patching, encryption, and backup and recovery. And then you need to clearly state or outline the incident response. So when I say incident response, okay, for example, if something happens, what should be a standard operating procedure to actually manage that incident? So when I say SOP, it says, okay, raise an incident, you need to do certain steps. You need to inform the leadership team. You need to inform the operations team. You need to increase the severity. Based on the severity, you need to communicate that particular the effects of or the I would say is the outcome or the what's the right word, consequences of so who are the incident. So you need to have all of this information in hand so that basically if something happens, at least you know you're managing that in a controlled way rather than just panicking and then everybody going everywhere and then just running around, don't know what to do and how to manage that, and then basically your leadership team loses confidence in the operational team managing all of this. So you need to have a clear set of guidelines. Again, you define that as part of risk management. Right. So again, you do all of this. How does it happen? So you need to have training. You need to have regular fire drills to actually manage all of this. I do want to give an example that we used to do as part of this, but I think there's only 20 minutes left. I'll just quickly walk through all of the slides that I have. Yeah, I think risk management in any organization is key. I think this is a fundamental pillar for any organization. I think if they don't manage risk properly, I think there can be severe consequences. I think you've seen the financial meltdown back in 2007. I think there are severe consequences. I think, and there are organizations which have a very good effective risk management, which could actually go through all of that trouble during that time. And I think one thing, what I believe is because of the policies and procedures, or risk management policies and procedures that they have in those organizations. So again, as part of risk management, you categorize them. So you have risk identification. They can be different risks. They can cyber threats, regulatory changes, market fluctuations, or operational failures. So they can be these. This is not a finite list of risks that are available. There are n number of risks, and it can be customized as well based on the domain that you work on. So you need to have a list of you need to identify what those risks are in each and every area, not just taking and then tailor them so that it fits for your organization. So you have risk categorization. So it can be financial, operational, strategic, compliance, or reputational. So you categorize this. So a risk can fall into multiple domains. So you need to group them appropriately. You need to have a risk assessment and analysis. I think so you can't predict anything at least the known risks that you're aware of. You just need to ensure that you need to evaluate the likely impact and the potential consequences of each of those risks that you've identified. People use quantitative modeling, stochastic, and a lot of modeling that are available, and depends on the industry. Qualitative, quantitative. Each and every industry has their own risk modeling. So people do different kind of risk modeling. I think people do that in cyber security as well. They do a lot of modeling, and just to simulate some of the threats that are currently that are happening in the world. You need to have a clear risk mitigation strategy. So you just identifying the risk itself is not enough. You need to have a clear plan of how do you manage those known risks. So this is not something that unknown risks that you're going to manage. So you need to know what are the risk mitigation or the actions or that you need to follow in case if a particular risk arises, and then how do you mitigate it, and then ensure that that's closed. Okay. So again, I'll quickly walk through. I'll share these slides later, and maybe you can go through them. Monitoring and review, communication, reporting, and governance and culture. Okay. Monitoring and response, I think this is also key. So I think we did say that we need to deploy procedures, frameworks, and do all of that. I think once you deploy all of this, you need to have an effective monitoring, and then you need to have an action plan to manage that incident. So why it matters? Why? So effective monitoring. So basically, if you have effective monitoring in your organization, basically it manages. So you can minimize. So you can't avoid the damage. If somebody is coming up with a new technique to actually breach your system, so at least you could minimize the damage if you have. You can identify it quickly. You can reduce the downtimes, and then you can avoid reputational damage. If you can address those attacks and vulnerabilities quickly and efficiently, and to enable all of this, you need to have proper documentation, clear communication, and then regular fire drills, as I mentioned earlier. So you need to have a periodic testing exercises. It can be network, anything. This applies for any domain. I mean, it's just not for like applications. It can be anything actually. It can be networks, it can be infrastructure, it can be anything. The other one is effective backup and recovery. So ensure that you have. So this is where data categorization helps you actually. So if you're dealing with any system that holds confidential data or highly restricted or restricted data, then you ensure that you have an effective backup and recovery plan. So now most of the workloads are moving into cloud. I think even in on-prem, people replicate their infrastructure like to a different data center real time with very low latency. But now I think now most of the workloads are moving into cloud where you can enable this. I think the cloud itself gives you that option. Like if a particular data center goes down within that region, you will have different availability zones within that region where it automatically switches into. But if the complete region goes down, then you need to deploy this backup and recovery. This is a business continuity and recovery strategy. It's called BCR. And then effectively you replicate your stuff to altogether different region that cloud service provider supports. ensure that your backups are regularly encrypted. Yeah. I think there's whole loads of stuff that you need to manage. I think I'm just scraping the surface, but I think if you actually go in depth into this topic, I think there's a lot that you need to digest and process. Again, why do we need, again, so as we discussed earlier, compliance and audit. I think this is one of the key things. So compliance is basically you adhere to all the laws and regulations of the land and that you operate on. Uh, yeah, and then enable audit. So when I say audit, it's not just you testing your procedures, but also you enable external teams to actually audit you. So with all of this that you've documented, all of these procedures, makes your life easy if somebody external to you and then wants to check whether you're complying with a certain framework or a certain regulation. So if you have all of those that I've talked about earlier, then it makes your life easy to provide that information for them to carry on and then certify you that you're compliant, what you say that you're compliant with. And if there are any findings, then basically that's a feedback loop, and then ensure that you actually plug that in into your procedures, your risk management and everything, and then ensure that that's closed, and then move on. Yeah. And the last one is the security training. Again, I think you can have all of these procedures and everything, but if people don't know how to operate and then how to follow those, then it's no good. So ensure that you have a clearly defined procedures and then processes that you need to make aware, or your employees need to be aware of those things and ensure that they follow in their daily routine to carry on with their work. Okay. Yeah, I think positive security culture. I think this is one thing that you need to ensure that your employees follow. They need to have a positive culture. They are always aware. Look for any suspicious things. Yeah, and then act upon it. Okay. So I've talked about conscious of time. I've got 10 minutes left. I think quickly race through all the slides that I have. Got a couple of them to cover. So what happens if you don't follow any of these processes that or the pillars that we talked about? I think there are a number of things that can happen, right? So you can have reputational damage, you can have a legal action, litigation, you can have financial penalties and fines, and most of all, basically, it's a big disruption to your business. I mean, if you don't protect your data, then what good it is? So effectively, if that leads to financial loss. So disruption to business operations would lead to financial loss, and nobody wants it. So these are the consequences if you don't implement a data security framework or controls. Okay. Okay, I think I touched upon, right? I think around the data breach, around M&S. I think there are a number of lessons that can be learned. I think now they can take that feedback and then just basically plug into their operational processes and then the security process, and ensure that that gap is plugged so that it doesn't happen again. I mean, if it happens again using the same procedure, then then there's something wrong. Right. Okay. I'll stop for a minute before I talk about, okay, what are the leading data security frameworks that are available in the market or in the wider world? There are a number of security frameworks that are, if you Google, you get a lot of them, but I've just picked a few. But these applies for most of the small and medium businesses, medium, large, and big enterprises as well. I think it's not necessary that you pick everything and then deploy everything. If you're a small organization, then you just need to pick and choose what's most relevant for you. So there are a lot of frameworks, I think, and then each framework focuses on a particular area. It's called NIST CSF2, which the focus area is risk and governance. Best fit for all organizations, whether it's national or global. It's comprehensive, flexible, risk focused. There's an ISO framework. It's international data-driven organizations, globally certified, privacy focused. This is CIS controls. Basically, these are practical controls. I think many of you would have used CIS. So I think this is the most common term when you build your images and then deploy them in any infrastructure, whether it's on-prem, Citrix, cloud, or basically, you don't want to pick an OS that's not CIS certified. What's CIS certified? We'll talk about that later in the slide. Basically, it tells you what are the minimum set of requirements that you need to have to deploy an OS image or any image, actually, not just an OS. It can be a container or it can be anything. So it's easy to adopt, prioritize, best practices. Basically, that gives you the first line of defense, i.e., basically your OS and everything are very efficient and strong. There is a zero trust architecture. So zero trust structure, I think most of the cloud and fintech and SaaS, basically, there's a big buzz around this. I think to ensure that, I think least privilege access is the key concept for this. There's another one. This is on MITRE and ATT and CK, just threat analysis. Basically, MITRE is a company leading in cybersecurity and then space. They do a lot of things. I think they do have a standard that's openly available for people to deploy to manage any cyber threats. Okay, right. So I think I've got 3 minutes left. So I just gave you a summary of all the frameworks that are available. I think I'll let you go through all of this. I think and this good information. I think I've just covered only a part of it, but I think there's a lot of interesting topics that you can. I think I'll quickly touch upon the last bit. Is this is a thing that this conference is related to, which is how do we use Gen AI and agentic AI. I'm sure most of you know Gen AI and what agentic AI is, so I don't need to go through all of that and how do you implement it. Maybe that's for another day. So a quick walkthrough. I think definitely Gen AI and agentic AI can help us to deploy all of this data security frameworks or customize it. I think the big advantage is that I think once you define a policy, deploy it, so Gen AI can actually monitor it for you, and it can learn things, and then based on patterns or anomalies or rule based. So it can be anything that the human can miss. But I think it can learn, and then it can instantly give you the option to remediate or how a response playbook should be. So you can have adaptive security policies and control. So basically, you can automate most of the stuff and then learn from the outcomes. And then it leads to faster incident investigation and forensics. Basically, if you have a log that gets sent to your scene, you need special skills to actually decrypt that. Ideally, if you can deploy Gen AI, basically, I'm not sure if anybody of you have gone through a scene system. The logs are horrible. I think it's very difficult to actually read them. Yeah, I think definitely Gen AI and agentic AI can actually quickly enable the operations team to ask questions in plain text and then and see where the actual problem area is. Right. So, and it also helps to support one of the pillars that I'm talking about. So it gives you continuous compliance and audit, map security controls, so whatever the controls that you deployed, and then I think it can map to the framework requirements that that your organization has. It can highlight any gaps, risks, or any stress from the existing policy that has been mandated. So you can quickly summarize the evidence, and if at all, if somebody needs to do an audit. Proactive vulnerabilities and risk identification. Again, I think there are special models which can actually help you to predict any vulnerabilities within your infrastructure. Enhanced security awareness. Again, I think this touches back upon the social engineering scenario. Okay, real life use case. So how is industry adopting these data security frameworks using Gen AI and agentic AI? So these are some of the examples that I picked up. So Global Bank, BBB, I think it's a South American bank. They use Google SecOps, powered by Gen AI, for their security operations. So yeah, I've listed the benefits. So significantly reduced detection and response times to threats, more accurate security alerts, so fewer false positives for SOC analysis, and then greater scalability. I think now they don't need to worry about protecting their on-premise or multi-cloud systems. So, and they can scale as well, so they can deploy any number of them without actually worrying about how to actually protect them. Basically, this aligns with the NIST CSF2 framework that I've highlighted earlier. So detect, respond, automatic detection, investigation, and action. Okay, the other one is, yeah, so this is a general use case. Using AI agents to continuously do security testing. So enterprises deploy autonomous agentic AI systems to simulate cyber attacks. Yeah, so they take a sandbox. So they don't do on their live systems. Basically, they take their sandbox environment and then assess how secure or how easy or how difficult is it to actually breach that infrastructure. So they use AI agents to autonomously attempt penetration using penetration testing, search for weak controls, or if you have any misconfigurations or IAM policies that you have defined, or excessive privileges or unpatched servers. So basically, they can autonomously run all of that, those agents periodically without any human intervention, and then highlight if at all if there are any gaps identified. And then you can basically you can tie that with the existing publication of any vulnerabilities either in Java or any system actually. I think take that information and ensure that that kind of penetration testing is done. So what are the benefits? So enable organization to maintain continuous security posture. So a solid security posture is good for any organization, not just for its operation, for auditing, compliance, and yeah. So yeah, proactively close gaps if at all, if there are any. Right. So I think summary and key takeaways. Not sure how much this has helped you, but no matter how much or how many controls or frameworks that you follow and adopt and deploy, there can always be new stuff that the threat actors can actually come up with and then infiltrate. So it's a cycle. Basically, you learn, adapt, implement, and then just go back again and then learn. And so basically it's a cycle that you need to follow. But if you ensure that your pillars or whatever that I've defined um, uh, earlier, if you apply those principles, so all of these security frameworks that I've defined, I think there's a lot of open source code available as well for you to directly pick up, customize, and then deploy it in your organizations. To use or to, and you can basically take that open source code and then customize it. And I don't want to go into the tools that are available to deploy all of this, because there's a whole host of tools that are available in the market to manage all of this. And people spend a lot of money to do this. I think the key thing is that the bigger organization is that gives them the flexibility to scale, to use those tools, but it need not necessary. But you can take all of this. Basically, you can instill these foundations within your development teams when they deploy their software, so that you worry less to manage the overall stuff that happens. So it's everything helps. So every little helps. So if your foundations are stronger, then you're better protected, and then there are larger benefits down the line when you want to manage it and then run it. On that note, I'll stop. Thank you very much for this opportunity, and it's been a pleasure. Any questions? Hello.
Yeah, thank you, sir. On behalf of the organization team, I sincerely thank you, sir, for delivering such an insightful and engaged session on tools and technologies for AI-powered cyber threat intelligence with good examples of data security frameworks. And your valuable knowledge, real-world examples, and clear explanations provided great learning for all participants. We truly appreciate the time and effort you dedicated to making this session impactful. And we are eager to engage with you again in future knowledge sharing opportunities, sir. Thank you, sir.
Thank you very much. Hope it's been useful. Thank you all. I think I should thank Prasad. I think he's been a good friend of mine for a very long time. So thanks, Prasad, for giving me this opportunity to speak in this forum.
Thank you, sir.
Thank you.
So the next session will start soon in 2 minutes. Already sir is in. Sir, join the session. So welcome back to everyone to our next session, 12. Now it's a privilege to invite our session speaker, Dr. Nagesh Bhattu Sistri sir, Assistant Professor and HOD Department of Computer Science and Engineering in National Institute of Technology, Andhra Pradesh, with 18 years. So it's a privilege and honor to invite you, sir. Sir, please start the session, sir.
Thank you, madam, for your kind words, and start session.
Okay, meanwhile, I just want to inform everyone that sir is going to give a session on topic integrating AI with cyber threat intelligence. So everyone make use of this good opportunity and gain good insights of this topic.
Recording in progress.
Is my voice clear and audible?
Yes, sir, audible, sir.
Actually, the
Your
conference or
screen
the
is
workshop.
visible, sir. Yeah.
Yeah, the workshop is pretty ambitious, and I think there is a lot of AI stuff that was put into the curriculum of this workshop. However, as I belong to academic fraternity, and then I have been working with differential privacy for some time now. I'll just bring before you the kind of work that we have been doing in the context of differential privacy. Privacy, as I think I don't need to emphasize on the last day of the workshop to tell you the importance of privacy and all. However, designing the algorithms which can offer some kind of privacy guarantees has been something uh, that was an idea for quite some time worked out by researchers. And there is one concept, actually the field actually span around a period of 20-25 years now. Initially, people try to fiddle with some concepts like k-anonymity and all, which found out to be having lots of flaws and all. And then there were some initial ideas of differential privacy, wherein there were fundamental results on what can be learned from the algorithm without giving the details of the individual's without breaching the individual's privacy. There is a formal notion of differential privacy was introduced by City and Barker. And that was the starting point of the research on differential privacy. And from then on, as you might be using these AI tools and all, every company like Google, Microsoft, and you name any company, all of them include into their tools these differential privacy techniques to incorporate some notions of privacy into their algorithms. Right? As we all know, the algorithms are quite powerful today, and they can uh, uh, they can solve some of the hardest problems of our real world. And what can be learned, the barriers are like they are crossed like anything, especially in today's AI world. However, there are fundamental notions of designing these algorithms, and I will be talking some of them, especially when the things that I have been doing with my students. Okay. Uh, in this context, it is very important to acknowledge one of the works on uh, including differential privacy in the context of deep learning algorithms. This is work published in 2016, and Martin Abbesi. And I think many of you are familiar with Ian Goodfellow and others. So this work has actually just show you the crux of these. Yeah. So as we all know, any machine learning algorithm, especially the deep learning algorithms, are dependent on computing the gradients of some loss function and all, right? So the loss function gradient, which is indicated here, that vector is added with some noise. So the purpose of this noise is to ensure that some notions of privacy are enforced, right? The kind of privacy notions that these people have found is that if you are working with a database and learning this algorithm, if the database has a tuple, right? So particularly about a particular person, if it is a face detection algorithm, if the algorithm is about has understood when a particular person's face, then that details should not be revealed. The learning algorithm ultimately learns some parameters. Right? So the parameters should not reveal individual's identity. Right? So that's the notion of privacy, this differential privacy guarantee. Okay. What is differential privacy? Formally, the notion of differential privacy is any paper on differential privacy, you see roughly the same definition. So the mechanism that you have to learn from two adjacent databases, S and S prime, should ensure that the difference between them is bound by log probability ratio is especially bound by epsilon, and then with the probability given by delta. So the notion of differential privacy is called epsilon delta differential privacy. Right. So what is this idea? So the databases that you are taking are with and without an individual. And when the learning algorithm is taking inputs from learning from either of these databases, the difference should not be it should not be much, right? So that's what this guarantee talks about. So the bound is epsilon, and that is also ensured through something called probabilistic guarantee, that is the delta. Okay. Epsilon tells you the bound on the differences probability difference, and then the probability tells about which what is the gut about this happening. Right? So this is some notion of differential privacy, and so this paper was written in the differential privacy kind of idea was there for some good time by then, right? That was around 12 years or 14 years of work have happened. And this paper especially has tightened the notions of differential privacy, and without losing when you're adding noise, actually the noise can hamper the learning algorithm. Okay, so as all the earlier efforts have found the notions of differential privacy in slightly different way. The bounds that they have found were much relaxed, and because of which they were forced to add more noise. Okay, so the algorithm, when it is adding more noise, then what is being learned will get affected, and the learning algorithm will not serve a good purpose, right? So the effort is always effort kept by these guys is to tighten the analysis and ensure certain kind of notion of this differential privacy called epsilon delta differential privacy without affecting the loss, right? Addition of noise is adding, hitting the learning algorithm. Without hitting the learning algorithm, how to design the differentially private algorithm is what these people have worked on. And they have shown some fundamental results on momentum accountant and different way of accounting this differential privacy. And it's a breakthrough result in this set of works. And then I worked with one of the PhD students and some of the other students that I have here, and just present some kind of work that we have done using the basic notions of differential privacy. By the way, bringing privacy using differential privacy is not the only way of bringing privacy. There are lots of other schemes by which one can bring privacy. One is using blockchain. One can bring privacy. The other one is there is something called secure multi-party computation that has an established literature, and that can also be helpful to achieve differential privacy. Not differential privacy in the context of design of algorithms, learning algorithms especially. And then there is something called homomorphic encryption, which allows the computations to be done on encrypted data, and only certain things that the algorithm is meant for only will be revealed, whereas rest of the things will be nothing will be revealed beyond what it is designed for. And these are all especially useful in the context of autonomous algorithms design and so on. And especially when we are in an era where nothing can be. We have been using all the tools that we use day in day out without understanding the kind of implications that they have. Right? So we use our social media tools and so on without bothering about what uh, what is the kind of inference that they can do and so on, right? But that so the notions of these privacy and all are especially important in the context of all these tools, social media tools, and then the internet that we have been using, chat that we have been using. Lots of things can be inferred by them. That I have been doing with one of the scholars. Yeah, the problem statement that one of the scholar was working on is finding influential nodes in a social network. So the problem is called influence maximization. We are given with a network of nodes, and the objective is to find out the set of nodes to target so that the influence of those nodes is maximum. The spread is maximum. So you reach out to them, and they can lead you to the maximum number of people in the network, right? So this is a very important problem in the context of viral marketing strategy, especially. So if you want to give incentive, whom do you give so that you will have maximum reward, right? And also this can also be useful in strategically establishing a business in a kind of network kind of environment. Okay. So we are given with a social network, and we are given with some diffusion model set. The initial set of nodes, yes, is called the seed nodes, which are used for propagation of uh, the spread. Right? So the function sigma here is used for the indicating the size, expected size of influence propagation from S. And the set S, which maximizes the spread over the network such that mod S is equal to K, is to be found as part of this influence maximization problem. Right? So our seed set size is restricted to K, and which set do you select in such a way that it maximizes the influence rate. This problem is basically a combinatorial problem, and it can easily be shown to be one of the harder problems that we come across for graphs, because most of the graph problems that we come across are NP hard in nature, and this is no violation because we are dealing with sets, and there are exponential number of sets, and the design of algorithm has to be aware of these things, and there are always greedy strategies whenever we come across these NP hard problems. Right? So the greedy strategy is to uh, restrict our set space to a certain way of expanding these sets, and look for the K influential nodes in a greedy way, incrementally. So some of these slides I will share with you. However, all of it is not relevant for the discussion. So the work in that I showed earlier proposes an algorithm using momentum accountant method for achieving differential privacy. And whatever we have designed is achieving this influence maximization problem using learning of representations for nodes. Okay. I mean, when you have a network of nodes, we can use the connections between nodes to learn representations of these nodes. Okay, that's there are a classic bunch of classic algorithms inspired by I think you all know something called word to vec, right? Which is one of the classic representation learning algorithms, right? So inspired by that, there are a bunch of works that followed it called line, and I think there is one stretch of 6-7 years when every algorithm that was named after something to vec. It is most likely to be published in Premier Conference of Computer Science. Location to vec, distance to vec, whatnot. Graph to vec, node to vec. So many algorithms were there which were named after this vec suffix, right? So the idea is to just learn representations of these nodes in a network, and uh, some of them based on some noise contrast estimation loss function were very much successful. And we looked at the design of that, and what we have found is that we can rather use a GAN-based formulation to learn representation, solve this representation learning, and we use the two generator modules uh, in our network and one discriminator. The combination of source and destination vector representation is used as a diffusion probability instead of using some random probability. So these representations that were learned were used for inferring the diffusion probabilities. And that will help this self algorithm that was classically used in the context of greedy influence maximization algorithm to better target, find a better set of seed nodes. Okay, so this is what the kind of algorithm that we have worked on. Something that introduces to you that NP-hard formulation. Yeah, so this is the schematic diagram that describes the algorithmic context. So the source node generator, destination node generator. So there are two generators here. Both of them. We analyzed. I mean, there was some earlier work that used uniform representation learning for the source nodes as well as destination nodes. Then we thought of we analyzed that, and we felt like the role of distinguishing this role of these nodes in the network plays a vital role for a problem like influence maximization. And hence we used different learning modules for either of them. One is source node generator, another one is destination node generator, and the discriminator is able to work with this loss function, and is able to generate the fake examples that can the generator is able to generate fake examples that can fool the discriminator. Okay, so that's the overall network, and it is able to learn the representation of this network much better than the earlier inputs. Okay, so two generator networks are there, one discriminator network is there, and in the context of the discriminator, we added the privacy-inducing objective, right? The notions of differential privacy that I earlier showed using the momentum accountant method was induced into that, and we are able to bring notions of privacy guarantee, differential privacy guarantee in the context of this influence maximization problem. So the influence maximization problem as such can make use of the raw data that is available for over the network and learn representations and find out the k influential nodes. Our algorithm is able to guarantee the kind of guarantees given by differential privacy that if you are learning from two databases of these networks with only one node missing, nothing much can be inferred about the missing node. Right? That's the guarantee given by the differential privacy, and the same kind of guarantee is also ensured by our learning algorithm. You can so the later part is the seed selection and proving that the effectiveness of this approach still is met even though you are so ultimately when you are using differential privacy also your learning algorithm should not be as much affected, right? So the learned representations should not be disturbed as much. As you're not adding noise, it is highly likely that the basic purpose of this representation learning algorithm might be hampered. Right? So we have to prove it in the context of some experimentation to show that uh, uh, your basic node prediction algorithms and so on are still made. I think there are some kind of results that are there in the paper. I think I will share with you some of the things that have been done. Instead of focusing more into what this work has in it, I'll just show you another thing that we've been doing. This is with another student actually. Uh, the student has been working on another graph problem. So the earlier one is more aligned with the title of this workshop. This one is also on differential privacy. I mean, privacy only. Only thing is, it is about the fundamental problems of uh, the graph-based analysis. Okay, so there is something called a fundamental issue of click enumeration in graphs, and when we restrict our click to be of size 3, it is called triangle counting, and when we extend it for 4 clicks, it is a variant of it. Okay, so there are algorithms for this click enumeration and all, which are of interest and which were frequently published in VLDB and other places. And in this work, what we have done is I will yeah, so this local differential privacy is a concept where the entire graph is not completely with one central party. It is spread over multiple places, and this counting has to be done in a distributed way. So when we have all the data dispersed over the network, how do you bring this local differential privacy, still achieve the objective of finding 4 clicks to for this 4 click counting problem is what we have addressed. And as I need to just talk about yeah, how this can be achieved. Yeah, so 4 click is something like I mean the one that is projected here. So it can be achieved through a series of decompositions. Okay, first is to find some structure like this, followed by the second one. I mean the result of it is joined with this, and the result of it is further joined with this and with this. Okay, that is one way of doing it. And another way of doing it is shown in the, I mean, there are two, three other ways of doing it. So what we have shown is there is a shuffle algorithm that shuffle phase of the algorithm in the distributed setup, which is called class shuffle, which can enable this randomization that is typically achieved through the differential privacy kind of setup wherein noise is induced. That randomization itself is in a certain way called class shuffle, is able to bring the notions of differential privacy, and we have to still prove it with what is the kind of bias and variance that these kind of algorithms hold. And yeah, this is some work that was published in Codapsy, and this is to tell that there are fundamental results in the privacy differential privacy world that people are striving to and in the design of these algorithms, what is important is the reduction of communication cost. When we are talking about distributed computation, the emphasis is always the amount of the number of rounds of this computation that takes place before achieving whatever the algorithm is supposed to show, right? So, so with the kind of shuffle algorithm that we have proposed, we showed that the communication cost is reduced. So this is one of the works. This one is more technical in nature, so I am not too much going into details of this algorithm, as it spans multiple mathematical fundamentals. This time.
Nagesh sir, are you there?
Yeah, just I'm switching the presentation to the other one.
Okay, okay, sir.
Yeah, so this is actually I did not prepare this presentation. However, some of the student who is working on this layered randomized quantization. Again, it is in the context of differential privacy only, in the distributed setting, and this uh, uh, this is also pretty much a alternative approach pursued by the machine learning, deep learning, especially deep learning algorithm designers. That there is this concept of quantization, which was again meant for adding noise for stabilization and all. That aspect is again intertwined with the notions of privacy and this work that I just full screen mode is visible, right? Yeah. This work demonstrates the effectiveness of Gaussian LR2 in distributed stochastic gradient descent framework. Uh, whatever earlier works were there, they were using uh, the notions of primitive notions of differential privacy. This work presents Gaussian layered uses a quantization scheme called Gaussian layer randomization, randomized quantization. By adjusting the parameters of this, the quantization error is shown to be following expected Gaussian distribution. And this is again in the context of local differential privacy in the context of a distributed learning. So the algorithm will be learned in a distributed fashion, right? So the data will be lying all over, and the clients are all running this gradient descent, and how to achieve this how to make use of this layered quantization, randomized quantization, using Gaussian kind of noise for achieving differential privacy is what this work is about. So in this context also, again, the as it is distributed in nature, the objective is to achieve communication efficiency. Okay, so privacy has to be preserved, and there should be this notion of differential privacy that should be guaranteed. And at the same time, the communication cost has to be, I mean, it has to be optimal. Right? Optimal as in there is nothing like absolute optimality that can be argued in as in conventional algorithms and so on. But there will be, I mean, there is a lesser and more efficient algorithm. Right? So that's what it is all about. So so this quantized schemes they follow this line of thought. Can compression techniques alone concurrently ensure communication efficiency and then privacy and guaranteed modal convergence performance and all is the question, right? So this quantization is a kind of compression kind of technique where the size of the model is at a lower scale, right? And using such technique can be achieve communication efficiency and also the privacy, and also the model convergence of is also guaranteed, is the question that we had. And we worked with specific Gaussian quantization mechanism. This is the preliminaries for this distributed local stochastic gradient descent. This is the same paper that I referred earlier, moment and accountant theorem, for the context of this the local differential privacy. So the same paper that I showed earlier, that is Daniel Abadi's paper, is extended for this client level differential privacy, local differential privacy. So most methods add Gaussian noise before compressing noisy model updates to achieve communication efficiency and privacy preservation. So we aim to obtain privacy guarantees directly with only compression noise. So the crucial problem is finding compression technique to generate a controllable noise distribution. And what we use is called layered randomized quantization based on method quantization and layered multi-shift coupling to generate exact noise distribution. These are the technical details of this work, and what we are able to show is that the without doing this earlier approach is to add the noise before, right? So that was one step that we could avoid in our approach. This is also something that we have communicated to the venues, and we are in the process of getting it published. Yeah, these are some of the work that I have been doing in the context of differential privacy. I also have a PhD student who is working on multi-party, secure multi-party computation. This secure multi-party computation, as such, as I told earlier, it enables the principles of multi-party computation to achieve this guarantee of achieving security. So these are all different constructs that the research literature has. Differential privacy enables us to keep the data in the same format, right? So you are still using the same data, underlying data, and the learning algorithm has some kind of random noise addition schemes to achieve some guarantees of privacy. So whatever that learned will not be leaking individuals' privacy. Right? That is what the notion of differential privacy enables us. If you think of another kind of thing like blockchain, blockchain brings something like a auditable ledger, which can nullify the kind of advantage a central node has. Right? And there are blockchain systems that can provide privacy, still let everyone to communicate in a agreeable way, right? So those systems are also there, right? So blockchain systems are also used to again achieve multiple. A goal that is meant for everybody. That means a set of users are trying to interact with one another in a agreed manner, and beyond what the protocol is meant for, nothing else will be possible for the individual stakeholders, right? That's what the blockchain enables, right? And the other kind of formal designs are like federated learning. I think a lot of literature is being published in federated learning, and the uh, the fourth one is multi-party computation. I have a PhD student who is working on multi-party computation, who will brief you about the kind of work that he has been doing for the last one last semester. Let him join. I'll share with you some of these slides with the coordinator, and so that whatever literature link that we were following may be helpful for some of you who are pursuing research. Mr. Sunil is working with me and Dr. Purushotama for this PhD, and he has been working on the secure multi-party computation, a problem currently he is pursuing. He'll present whatever he was working currently. Uh, Over to you. Sunil, your voice is not audible.
Yes, sir, you're audible, sir.
No, my voice, not my voice. Is his voice audible?
Your voice is audible, sir.
Not my voice. Sunil has joined.
అండర్స్టాండ్
Hello.
అది వాయిస్ చూస్తున్నా అక్కడ సెట్ అవ్వట్లేదు
ఓకే. నీకు ఏదైనా కావాలా?
లేదు సార్ ఇక్కడ హెడ్సెట్ కనెక్ట్ చేశాను
ఓకే
అది
ఓకే ఓకే చూడండి, వస్తున్నట్టుంది చూడండి. Hello, madam.
Sir.
There is some error message that Mr. Sunil was getting that host is not allowing himself to get unmuted.
Okay, sir. We'll provide the host to Sunil sir, sir.
Yeah, please. Yeah, let him
Okay.
unmute, then it will continue.
Yeah, now Sunil sir can access, sir.
Hello, sir. Hello, madam. Am I audible?
Yes, sir. You're audible, sir.
Thank you. Good evening, everyone. This is P. Sunil. I'm a research scholar from Department of Computer Science under the guidance of Dr. Nagesh Bhattu sir and my co-guide from Dr. Purushottam sir from NIT Suratkal. So I'm working in multi-party computation. Uh, as we all know that in terms of crypto, there might be some like when we are encrypting some messages with one key, and the same key will be used onto the other side to decrypt the original message. So when we are using a word multi-party computation, we want to compute one function in a such a way that all the individual parties, whoever involved in the computing that function, so the data will be only the private data, whatever each individual has, will be kept secret. So as the definition states that set of cryptographic techniques that allow set of mutually distrusting parties to compute a function while revealing only the outputs. So we will get the outputs, but we don't know what are the individual inputs that we have provided onto that function. And that function will be publicly known to everyone. But the only criteria is everyone's individual private input will be known to themselves only. So when it comes to the property of MPC, we are having two properties. One is correctness as well as privacy. When I'm using the word correctness, any authorized subset of parties can pool their independent shares and reconstruct back the original secrets. And when it comes to the privacy part, no one, I mean, those who are unauthorized parties, they learn nothing about the original secret by pooling their independent shares. Maybe I will tell you these two properties in the coming slides, how it actually works on. So what is my motivation to design, or you can say designing a secure multi-party computation is there might be some Yahoo millionaires problem. In the problem, it states that there are two persons, let us say Alice and Bob, and they want to determine who is the richest person among the two, but they don't want to leak their respective net worth. This is one problem. Or other problem is e-voting system. 100 citizens or maybe more, they want to vote for some next mayor. So they want to learn the outcome of the voting, but they don't want to leak each individual's voting. So how will you relate these two problems? And there are many more problems. So these two problems, how will you relate to security? Means net worth with respect to Alice must be kept hidden from Bob, as well as vice versa. Similarly, when it comes to the e-voting, each party vote must be kept hidden, even if some of the participants collude. We must, I mean, so that if it is open to everyone, means the system will be corrupted, you can say. So few dimensions with respect to secure multi-party computation. Dimension 1 is some form of function abstraction. Dimension 2 is of network type. Dimension 3 is corruption capacity. Dimension 4 is corruption power. Dimension 5 is corruption characteristics. And dimension 6 is corruption time. So we'll go one by one. The dimension 1, there is some form of function abstraction. What it states is in what mathematical forms we can design some specific application, you can say, or you want to compute some any other function. So let us say, as I told earlier, millionaire problem or e-auction problem. We need to see who among them will be the richest one or who will be the next mayor. So we can apply some Boolean gates or Boolean circuits where AND or XOR or NOT gates. And when it comes to the general MPC protocol, it can compute any function. So it may the arithmetic circuit addition and multiplication over the fields and rings. As we all know regarding the fields and rings, these are all in number theory. Will define the fields as well as rings, some form of closure properties, associativity properties, as well as commutative properties. So this is dimension 1. So dimension 2 is network type. Once you design the dimension 1, we need the data to be transmitted from one system to another system, you can say. So that for the first one is synchronous, other one is asynchronous communication model. So when I'm using a word synchronous, there should be some, it follows some global clock, you can say. So the messages are exchanged in a fixed round. There must be some time limit will be given for the messages to be exchanged. If the time, let us say there will be a delay, then the missing message we can imply it may be corrupted. So when it comes to the asynchronous model, as we all know that asynchronous model, internet is an asynchronous, it's a real time. So the message can be delayed arbitrarily. So it cannot, we cannot tell the delay is an either honest or malicious. So when I'm using a word honest means it should not be, not corrupted by the adversary. Malicious means corrupted by the adversary. So, and there will be no shared global clock in terms of asynchronous model. The dimension 3 is corruption capacity. So in this dimension, the threshold and non-thresholds, attacker can corrupt up to T out of N parties. So there will be N equals to 4 and T will be equals to 2. So out of 4, 2 may corrupt. So the actual corruption set is hidden here. And when it comes to non-threshold means some specific subsets, we can say a set of 3 may corrupt, a set of 2 may corrupt, a set of 1 may corrupt. When it comes to the dimension 4, we are having some corruption power. This is bounded and unbounded adversaries. So when I'm using a word unbounded adversary means adversary having the full of flexibility to work on it, unlimited computing power. So here the protocols are simpler. When it comes to the unbounded adversary means it's a polynomial time probabilistic model. So it uses the cryptographic assumptions. Protocols are here very complex and no everlasting security. And dimension 5 is corruption characteristics. The first one is passive or we can say semi-honest. When I'm using a word passive or semi-honest means adversary only observes the messages. He eavesdrops the communication, you can say. And the next one is crash or fail stop. There might be a situation comes, the party may halt unexpectedly. So it cannot rejoin the protocol. Maybe this crash is some stronger when compared to the passive. And the next one is Byzantine. It's an active adversary or malicious, we can say. It can send an incorrect message or harmful messages. And it's the strongest adversary model among the three. So the last dimension is timing of, corruption time. The first one is a static one. The next one is adaptive adversary. So when I'm using a word static adversary, before doing some execution, the corruption will be initially fixed. And when it comes to the adaptive adversary, it will corrupt the parties during the execution. We can say on the fly also. So each of the dimensions are independent. So each dimensions having cardinalities, if we compute, then it allows us for 96 different combinations of MPC protocols. So the next one is how to share a secret. This is comes under the area of visual cryptography. So as we all know that there might be, we are ready to consider a bank where a password will be, server password will be with the bank manager only, or we can say the manager may be trusted person. So to whom we are giving the key, there might be possibility that the manager may cause some brain damage, or we can say he may get compromised. So how to protect our key? This is one area developed by the Adi Shamir in 1979. So the motivation to design this, paper is there are 11 scientists who are working on a secret project. So they wish to lock up a document in a cabinet. So the cabinet can be opened if and only if 6 or more 11 scientists are present. So what is the smallest number of locks it needed is, if you compute the combination, it will give you the result of 462 locks. And what is the smallest number of keys to lock each scientist must carry? So 252 keys per scientist. The number is very large, and it becomes very exponentially worse also if the number of scientists will increases. So let us say how to protect a key. In order to protect it, there are one scheme that is threshold schema, T, N schema, and other one is N, N schema. So in this T, N schema, our goal is to divide the secret D into N shares. That is D0, D1, D2 up to Dn minus 1. So any T or more pieces can reconstruct D, and any T minus 1 or less pieces will reveal no information. Let us take a value of D, some T, N means N equals to 5 and T equals to 3. So how the value this T equals to 3 is come into the picture is that N value is equals to 5. This 5 by 2 is equals to 2T minus 1. So that will gives you the value of T equals to 3. So more than 50%. So the threshold schema is a fault tolerant. It tolerates up to N minus T plus 1 failures at least. So it can be done by using a Lagrange interpolation method. This is a polynomial interpolation where Q of x equals to A0 plus A1x plus A2x square, so on up to A t minus 1 x to the power t minus 1. So our aim is to share as well as reconstruct. So what is my main goal is that instead of A0, if we replace that A0 with D value, secret D is embedded into this pre-term that is A0. So we can achieve our original secret in the later also. So this is Lagrange interpolation method where t plus 1 data points x0, y0, x1, y1, so on up to xt, y2, where this L of x is equals to summation of yj, lj of x, as well as this lj of x will gives you product of x minus xm by xj minus xm, where j and m should not be equal. If it is equal, since it becomes 0. So we'll take a secret value d equals to 5, and the polynomial if we embed it, then this 5 plus ax plus 2x square, where a1 value is 1 as well as a2 value is 2 we have taken here. That is randomly we have taken. So if we apply x value equals to 1 to 5, then those values will be d1, d2, d3, d4, d5. These are the shares. As I told you, this is a 3, 5. So if any of the 3 participants may combine together at the later case, that means what? First they compute the shares, and the shares will be distributed, and we deleted that polynomial, whatever we constructed earlier, that is 5 plus x plus 2x square, and whoever the shares will be, distributed. Later the participants may collaborate each other. Then again, after applying this Lagrange interpolation, we will get the original value. This is a basis polynomial, how it is working. So we are computing L0, L1 and L2 with those values only. So at the end we will combine together and we will get the original value, that is 2x square plus 5x plus 5. So the value of D again, it will be recomputed. And if any 2 or more fewer shares will combine together also, there will be no information. This is T comma N scheme. Another scheme is that I am working here a N comma N schema. It states that if all the N shares will combine together, then only we will get the we can get the original secret. So this is a Boolean XOR and modular arithmetic based N comma N schema for multi-secret image sharing scheme. Earlier days, traditional visual secret sharing protect only single image. Right now, we are having a multiple images. So multiple images will be combined together, and that will provide it to the other side, onto the receiver side, and they again combine together. That will get all the multiple images. In between a sender and receiver, there might be possibility that the adversary get into the picture, then he will get the random images, or you can say the noisy images. So this one is a literature survey where some of the authors done their work regarding grayscale images, binary images, K command schema, as well as some verification of the secret images, and Boolean based some leakage, cover images, as well as eliminated pixel expansion using random grid techniques. So the existing algorithm, there are some few algorithms which are existing. There might be, flaws in this. Let us say n equals to n is even. These are the, f1 equals to I1 XOR I2 XOR so on up to IN if n is even, else f1 equals to I1 XOR I2 so on up to IN minus 1. So, and compute the function using reverse bit, f2 equals to reverse bit of f1. So if we take the value of n equals to odd number, let us take the value of n equals to odd, then this s1 equals to n1, which is equals to I1 XOR f2, s2 equals to I2 XOR f2. And if we combine the two shares, we are getting I1 XOR f2 XOR I2 XOR f2. That will gives you I1 plus XOR I2. So it will reveals the direct relationship between the secret images. As I told that this is an N command schema. So our input is n secret images, means our output should be all the n secret images once combined together. All the n shares will combine together. Then only we will get the original image. But even with the less number of secret images, we are getting the I1 XOR I2. So that violates the confidentiality. Similarly, when it comes to the existing approach 2 also, there they have taken some temporary shares T1 equals to I1. I equals starts from 2 to n. Then again, if we compute here, T2 also, this T2 equals to I2 XOR T1. And instead of T1, we can write again I1. So if we combine these two again, we will get again I2. So that is an original image. That is I2 represents here an original image. And this S1, S2 recovers I1, I2. So adversary can obtain the full or partial secrets with fewer than n shares are available. Similar scenario with the existing approach for 3 also. This one is on the left hand side, whatever it is, here it is sharing procedure. On the right hand side is a recovery procedure. So this T1 equals to I1 mod 256, and again T1 Ti equals to II plus Ti minus 1 mod 256. For this one, I've taken one example. For this one, let us take some I1 equals to 20, I2 equals to 30, and I3 equals to 40. So T1 equals to 20 and T2 20 plus 30 mod 256 will give you 50. And this is a T through. These are temporary shares, and this reverse fit of S1, S2, S3 will gives you some 40, 76, and 90. So reverse fit of 20 means if you compute this in a binary form, and again if you do the reverse, we will get 40. Similarly, 76 and 90. So if the attacker will reverse those bits, so that become again 20, 50, and 90, and it can easily recover the values. So the proposed I propose this one. I'm working with this one right now. So this computing, we have taken n secret images. Again, my output is n shares from S1 to Sn, and generate n minus 1 random matrices from R1 to Rn minus 1. And I need compute nth share using XOR operation. So instead of directly XORing the secret images, that is I1, I2, In, I'm again XORing with R1, R2 up to Rn minus 1, so that if the two meaningful images will combine together also with the help of, again with the random matrices, then again there will be some noisy image we will get. And for the remaining shares, that is Si equals to Ri. Similarly, for the proposed approach 2, again I have taken the random matrices of same size I1. Here again noisy image N1 equals to Ni equals to II XOR of R1, and construct the share images S1 equals to N1 and S2 equals to N2. Similarly, I equals to 3. I is equals to 3 to N. So this S3 is equals to N3 XOR Ri R2 plus R1. So if you do the computation, maybe I can show you this screen. If we do mathematically, we'll get like this. These are the n equals to 3, and I have taken the input images. Original secret images, and these are the random matrices. So n1, n2, n3. Again, if I combine this to n1, n2 using XOR operation, I will get I1 XOR I2, XOR R1, XOR R2. Similar scenario with n2, n3 also. So if I combine the shares, those S1, S2, S3. So S1, S2, again I will get I1 XOR I2, XOR R1 plus R. So similar scenario with S2, S3 as well as with S1, S2. So this will give you some randomness. And this is a proposed approach 3. In this also, I've taken some random matrix from R1 to Rn minus 1. And I've taken addition modulo mod 256. And for I equals to 1 to n, this n1 equals to I1 plus R1 mod 256. And this reverse bit of operation, again, it will be holds the value of, T1 will hold reverse bit of N1 and construct the shares with S1 equals to T1 XOR T2 up to Tn. So for I equals to 2 to n, this again S1 is S2 equals to T2, T3, so on. So the partial knowledge will remain infeasible without all the n shares. So for the experimental results and symmetric matrices, correlation coefficient computed. If it is value is equals to 1 plus 1, that will give you the original recovered image, as well as root mean square computed. That values gives you 0, means it's a perfectly reconstructed. And peak signal noise ratio, that value is again it will give the higher value PSNR, that will give you the perfectly reconstructed the original secret images. So for the proposed 1, 2 and 3, for the grayscale images, these are the secret images from I1, I2 and I3. These are the shared images S1, S2, S3, which are noised images, we can say. And this is a recovered image. Similarly for the color images also. And this one is a histogram for the both secret images as well as the recovered images. And when it comes to the future work, we are whatever the images that are shared from the original secret images, there might be few more works we need to improve it. So one is verification, whether it coming from the original source or not, or it may be the possibility that someone may compromise or someone may corrupt it. So we need to authenticate the shares also and prevent it from the denial of service non-repudiation. Once when I'm using a word non-repudiation means once it is signed, we can say in terms of crypto, it cannot be denied by the recipient. So these are the enhancements we need to, I need to work on it. And these are the references where we worked with, I referred these papers. Hello, sir. Hello, ma'am. Hello, ma'am. Hello.
Yes, sir.
I completed this MPC.
Okay, sir. Okay. Thank you, sir, for your valuable time and effort.
Thank you.
Nagesh, sir. Nagesh, sir, shall we wind up this session? Okay, all participants, we can wind up the session and we can start the next session at 5:15 p.m. Welcome back to everyone. So before starting the session, I just want to inform everyone at 6:45 there will be online test, assessment test. So everyone have to participate in the ATAL FDP portal. So we have shared the screenshots in our FDP group. So you can go through that, and all participants have to give your test in ATAL FDP portal only. Then only the test will be considered. And there are 20 questions, and the time duration is 45 minutes. So that start from 6:45 to 7:30 p.m. And once the session is started, you should not come out of the session. You should complete within that time limit before 7:30 p.m. And if you have a mistake, if you're out of the session, that exam will be closed. The test will be closed. So be clear on that. You should give your assessment only in ATAL FDP portal, and the timings are 6:45 to 7:30 p.m. And after that assessment at 7:30 p.m., we have a validity session. Apart from validity session, we have feedback also. So today's 3 session attendance, come feedback, and overall feedback. All these 4 things you have to submit for getting the participation certification. So please remember, at 7:30 p.m. we have validity session. Okay, all the best. After completing the session, the exam will start at 6:45 p.m. So before moving to the session, I just want to invite our next speaker, Mr. JNV Krishna Rao sir. He is the technology lead at Infosys, North Carolina, USA. Sir, please start the session, sir.
Hello everyone, good evening. Yeah, today we will discuss about challenges of AI in cybersecurity. Share my screen. So today we will discuss about challenges of AI in cybersecurity. So first, what is AI? What is AI in cybersecurity? AI used in cybersecurity to detect threats faster and analyze the amount of data and reduce the human workload. We know that AI is very useful. It can detect threats faster, analyze large amount of data, and help reducing human workload. Okay, but AI is not perfect. It also creates new challenges and risks. So the integration of AI in cybersecurity, we have significance of benefits, but there are a lot of challenges as well. So understanding of the challenges crucial for organization to enhance their security posture using AI technology. In this session, I will explain these challenges one by one, such as a problem with the data, system integrations, new threats, and ethical issues. Understanding them is an important for building a strong security system. First one is data quality and integrity. So basically, AI learns from data. Everything is data. So AI learns from data only. If the data is wrong or incomplete or poor quality, whatever, so it's basically depends on quality of data. So then AI will also give wrong results if it is any of these data is not proper. So it will give wrong results. For example, if AI is trained with data that has mistakes, it may fail to detect a real cyber attack, or it may raise false alarms. This is why data cleaning and validation, updating are very important. So we must always make sure that the data going into AI is correct and unbiased. Otherwise, AI will not effective. So, making it essential to ensure data integrity, organization must implement strategies for data validation and cleansing to maintain AI effective in cybersecurity applications. The next one is like algorithmic bias and fairness. So another problem is bias in AIs. What is bias? Bias means unfairness. If the training data itself is biased, then AI will also behave unfairly. For example, it may wrongly target the certain users or ignore threats from other groups. This can create trust issues and ethical problems. So organizations must regularly check AI models and bias and take steps to make them fair and balanced. So the next one is like continuous learning and adaptation. So like not only AI or cybersecurity, whatever. So the cyber attacks are changing every day, right? So hackers keep inventing new ways to break into the system. So the technology we can use it for good and bad, like that. Hackers also always they will do continuous inventing the new ways to break the system. So AI must also keep learning and adapting. But there is a challenge here. Like, so if AI learns too slowly, if you are not updating it up to date, it may not recognize the latest attacks. That's why we need balanced approach where AI keeps updating itself while also maintaining the stability. So enabling AI to learn from new threats without compromising existing knowledge poses a challenge. And next come to compatibility with existing system. So adding or integrating AI into some organization cybersecurity system is not always easy. Yeah, it's always not easy. Many organizations already have existing tools and systems. If AI is not compatible with those, it may not work properly. So compatibility issue arises, making it essential for organization to conduct through assessment of their current system before implementing AI tools. So for example, the AI may not connect well with the older softwares or may require challenges in existing system. So before using AI, companies should carefully check whether it will fit into the current system or not. So interoperability issues. Even if AI works within one system, it also need to work smoothly with other systems. Cybersecurity involves many tools and technologies like firewalls, monitoring systems, and alerting systems. If AI cannot communicate properly with these tools, it creates problems. That's why standardization and collaboration are very important to make AI work well across all the systems. So, uh, to deploy, we need to discuss some complexity of deployment. Deploying AI in real life is not simple. It requires planning, resource, and trained staff. So deploying AI solution in cybersecurity involves intricate process and challenges. Organizations must navigate various operational and technical hurdles, including resource allocation and workforce training. A methodical approach to deployment is crucial for ensuring that AI technologies are effective, utilized without disrupting ongoing security. If AI is deployed without proper planning, it may disturb the current security operation, which is a big deal. For example, it may give too many alerts or may not integrate smoothly. So companies need a step-by-step, careful deployment process with proper training for their teams. Threats and vulnerabilities in implementing it. So uh, we talk about adversarial attacks on AI model. So AI models are susceptible to adversarial attacks that can manipulate their behavior, leading to incorrect prediction and decisions. AI itself can be attacked. Hackers can design inputs that looks normal to us but confuse AI. For example, they can slightly change the malicious file so that AI wrongly think it is safe. This type of trick is called as adversarial attack. To prevent this, organizations must make their AI system strong and test them against such attacks. For example, oh, how hackers trick the AI in cybersecurity. I will tell. Okay, so hackers also will have plan. Hey, suppose a hacker wants to steal money from a bank account, but he knows the bank AI security system is very strong. So instead of attacking directly, he try to trick the AI itself. What he will do is like he don't attack the bank system directly. The hacker slowly start injecting fake normal looking transactions into the bank system. So he will start doing those things, but he don't attack the system directly. But the transactions looks like normal. He will start using like that on daily basis. This transaction looks harmless, but actually hide small sign of fraud. Over the time, AI begins to learn that these fraud patterns are normal. So he will launch the attack like that as a normal behavior. Now the hackers move a big fraudulent transaction using the same pattern. Since the AI has already been trained to think this is safe, it does not raise any alarm. Bank system lets the transaction go through. Aftermath, by the time the fraud is detected by human auditors, the hackers has already withdrawn money. The AI failed because it was tricked with poisoning training data. So basically, AI also need very good data and training. Exploitation of AI systems. As a AI used more in cybersecurity, it also become a target for hackers. If attacker exploits weakness in AI, they may steal data or misuse the system. If AI is not protected, a hacker might trick it into ignore the certain threats. That's why it is very important to regulate, test, monitor, and secure AI systems. AI defense mechanisms and implement strong security measures to protect these valuable assets. So the emerging threat landscapes are like the world of cyber threat is always changing. The landscape of cyber threats is constantly evolving, driven by advancement in technology and shifts in attackers' tactics. Attackers are now using AI to launch more advanced attacks. For example, creating fake videos, fake voice, or more realistic phishing emails. So AI spam filter blocks suspicious emails. Okay, but sometimes they also block genuine ones. Hackers may use AI to create fake voice calls, which we call as deep fake scams, to trick the people into giving passwords. AI can help us detect these new threats, but at the same time, it also faces challenges in handling unknown and unexpected attacks. So organization must stay updated and keep improving their AI systems. And now we'll discuss about regulatory and ethical concerns. Compliance. Basically, compliance is the major role in cybersecurity. So it is every organization's responsibility to maintain the compliance with data. It's a law. Basically, it's a protection law. When using AI, organization must follow data protection laws like GDPR or CCPA. These laws protect people's personal data, such as names, emails, or financial details. Companies do not follow these rules, they may face legal fines and loss of trust. So, any organization, the trust is the main moral for any organization. Compliance with laws is very important when using AI in cybersecurity. Failure to adhere to these requirements can result in significant legal issues and reputation damage. So developing a clear understanding of legal landscape is essential for organization to navigate the complexities of AI and data protection. Now, ethical use of AI in security. The ethical implication of using AI in cybersecurity are profound, with potential impact of privacy and civil liberties. Organizations must establish ethical guidelines governing the use of AI technologies to ensure responsible practices. This includes careful consideration of how AI is deployed and monitoring for unintended consequences. AI must also be used in ethical and responsible way. This means it should not misuse people's private information or cause harm to the people's rights. Organizations should set ethical guidelines for AI use. For example, deciding how AI can be used, what kind of data it can process, and what limits should be followed. This ensures that AI used fairly and responsibly. Accountability and transparency issues. One big question is, who is responsible if AI makes a mistake? As AI system makes increasingly significant decisions in cybersecurity, questions around accountability and transparency arise. Organizations must foster a culture of accountability, ensuring clarity in decision-making process involving AI. Additionally, implementing measures that enhance transparency can help build trust in AI system among the stakeholders of and the public. For example, if AI fails to detect an attack or if it is wrongly blocked something important, who should take the responsibility? This is why organization must have clear accountability rules. they must also make AI decision transparent, so people understand why AI took the particular decision. This will help build trust in AI systems. So data quality and bias. So AI relies on large data sets. So poor data leads to false or positive negatives, which are called as alarms. Bias in training the data accuracy. Poor data can lead to mistakes. Bias in training data can be cause unfairness. Explainability. AI models often work as black boxes, difficult to interpret decisions, and lack of transparency and reduces trust. AI must handle massive data streams, resources, intensive computations, lack of transparency reduces and trust. So handling very large data is difficult and resource heavy. Too many false alarms can overwhelm the people. So even some organization using AI, human oversight is still necessary. High rate of false alarms reduces efficiency of the AI. Coming to security of AI models, them the hackers stealing models, poisoning them with wrong data, or insiders misusing the AI system. Also, since AI needs sensitive data for training, privacy problems may arise. That is why organizations must secure AI model carefully and protect people's private data. AI requires sensitive data for training. Risk of misuse of privacy violations, compliance with law is very critical. Future challenges. In the future, cyber threats will keep growing and changing. AI must keep up with these changes, but we also need human judgment along with AI. AI cannot replace human fully. It should work together with people. Also, since cyber crime is a global, countries must cooperate and sharing information to fight these threats. So balancing automation with human judgment is very important. And possible solutions. To solve these challenges, we can robust AI training. Train a AI model with strong and high quality data. Basically, data is very important to train AI. And we have to use explainable AI so people understand AI decisions. Continuously monitor and audit AI system. Auditing also plays a vital role here. What kind of data we are using, whether we are following proper compliance or not. And we have to encourage collaboration between industry and universities. Like, so we can learn, improve faster. This picture gives like risk and challenges of AI in cybersecurity, uh, in which like misinterpretation, cybersecurity skill gaps, regulatory and compliance issues, bias, consideration. We have discussed all these large data requirements, data unavailability and manipulations. So addressing the challenges of AI in cybersecurity is essential for organization aiming to foster robust security frameworks. By understanding the complexities of data quality, integration, and ethical consideration, organizations can effectively leverage AI technologies. Continuous assessment and adoption will be key to build resilient and cyber security systems equipped to handle evolving threats. Thank you, everyone. I'm done with my session.
Thank you, sir. Krishna sir, thank you, sir. We extend our heartfelt thanks to you for delivering a highly informative and insightful session on topic challenges of AI in cybersecurity. Your expertise and clear explanations gave participants a deeper understanding of this critical domain and greatly enriched today's session. We are eager to engage with you again in future knowledge sharing opportunities, sir. Thank you, sir.
Thank you, ma'am.
Okay, all participants, by this session we can wind it up, and we completed all the 13 sessions, and the test will start sharply at 6:45. The test time is 45 minutes with 20 questions. So everyone have to submit your test only in ATAL FDP portal. Or remember that, only in ATAL FDP portal. Once you go through your ATAL FDP portal, you can see the assessment tab and you can submit your test there. Okay, after the test, you can again come back to this Zoom link, the same Zoom link what we have shared in the WhatsApp group. At 7:30 p.m., we have the validity session. In this session, we'll be giving the feedback link, the overall feedback link of this FDP program. So that attendance is mandatory. So if you provide that attendance only, everyone will get at your participation certificate. So the test begins at 6:45 p.m. 6:45 to 7:30 p.m. There will be 20 questions. Everyone have to answer it. And at 7:30 p.m., the test will ended automatically. So you need to submit before that. Okay, any doubts? Okay. So we can close this session and we'll come back again the same session at 7:30 p.m. So in the WhatsApp group, we have provided all the guidelines about the test and the material is provided in the Google Drive. If you want to prepare meanwhile, almost there is 45 minutes to begin the test. So you can prepare well by doing reference to the Google Drive. We have some documents in the Google Drive posted in the WhatsApp group. You can prepare from the documents. Thank you. Thank you, everyone. We'll meet you again at 7:30 p.m. after the assessment test. Dear all participants, so there is an issue in submitting the assessment. Don't worry, we have, might be this is because all FDPs have, throughout the India, they have given this only this time frame, like from 6:30 p.m. to 7:30 p.m. So might be the AACT portal the server was busy. Don't worry, we have sent a request to reschedule the test. We have just requested, we will see what happens. Meanwhile, as the session is recording, you can get back your concerns so that it will be recorded and we can ask to the AACT team. So we will make, give permission to unmute to everyone. So one by one, you just tell your concerns so that it will record and we can approach to the AACT team. Anyone can, if you have any concerns, please let us know. If you're not able to speak, at least you can put your concerns in the chat box. Jayashree madam. Jayashree madam, please give your feedback. Like if you faced any concerns for submitting the test, you can put it here, madam. You need to unmute your session.
Hello.
Yes, madam.
Hello, good evening, ma'am. I didn't get any of the problem, ma'am. I submitted the assessment, ma'am.
Okay, miss. So how did you just give your feedback of this ATAL FDP, madam?
Hello, ma'am.
It's
Hello,
good,
madam.
ma'am.
Hello.
Vijay sir, 1 second, sir. One madam is completing her
Okay.
feedback. 1 moment, 1 minute. Yeah, madam, please go ahead, madam. Okay. Vijay sir, you please go ahead, sir.
Madam, good evening, madam. My name is Vijay Raju.
Yeah, good evening, sir.
I sincerely tried from the 6:45 p.m. onwards. Till now, I am unable to get the examination. I tried in many browsers, Google, Chrome, Firefox, Edge, Apple browser also. But I didn't get the examination portal. I am logging. After login, I am selecting the assessment. After selecting assessment, it is taking to 5 to 10 minutes. After taking 10 to 5 minutes, it is simply saying only displaying empty page. Only question without question details. Question number only it is displaying. So I am not got at least one chance to write the exam. I don't know how others has written the exam. And my internet speed is more than 60 kbps, 60 mbps speed also. I have tested and I tried in all the browsers. In cognitive mode also I tried, but I am failed to log in and get the examination. So kindly, if possible, arrange another time of session, or else you can alternatively you can conduct the exam in the Google Forms. Because of I have attended more than 20 number 20 or 23 number of ATAL FDPs. So in that also many times I faced the same problem. first they are asking to be appear in the ATAL portal, but ATAL portal never will work perfectly. And later they will connecting the Google Forms. So once take all these things into consideration and rearrange a slot, else you can have a alternative of assessment.
Okay, sure, sir. We'll take this point and we'll mail the same thing to AICT team. If you get any Google form, we'll update you in the WhatsApp group, sir. Thank you for your feedback, sir. Anyone others facing this issue? Please put a feedback here. KSS Narayan, sir, do you want to give any feedback? Please go ahead, sir. So you need to unmute it. Your voice is not audible. Narayan, sir. Your voice is not audible, sir.
Good evening, everyone. I am
Yes,
KSS Narayana, working as assistant professor in the Department of CSE AML, Prasad V. Pottuli Siddhartha Institute of Technology, Vijayawada. At the outset, I would like to congratulate all the organizers for successfully completing and conducting this FDP on AI-powered cyber threat intelligence. So among the many insightful sessions, I would like to especially highlight the contributions of Dr. Alun Balan and Dr. Nagaraju Baideti from NIT Nagaland, and also the remaining sections of the other resource persons also very much helpful to enlighten ourselves and also learn from the other distinguished speakers from the academics as well as the industry people. They have given a fruitful information to us. And overall, this is an excellent session for us to gain some knowledge and how that cyber threat intelligence will be plays a crucial role in our networks. Thank you for giving this opportunity.
thank you, sir.
Thank you, ma'am.
Thank you for good feedback. Anyone? Anyone, do you face any concerns or please give your feedback? Nageshwari, madam, please go ahead, madam.
Okay, ma'am. Good evening to one and all. This is Nageshwari. I am working as a assistant professor of IT department in SRKR Engineering College, Bhimavaram. Especially this FDP has been very helpful in enhancing our knowledge, especially in AI tools, cyber security, and data protection. And we sincerely thank the IT department of Swarnandhra College for organizing this FDP. And a special thanks to the coordinators for their constant support. And we also extend our gratitude to all the ATAL FDP speakers for sharing their valuable knowledge and data throughout these 6 days. And this program has also inspired us with new ideas for future works and in research work also with AI tools, with the help of AI tools and data security. So thank you one and all.
Thank you, madam. Anyone else? Please share your feedback. Anyone else? Can you share your feedback? And if you face any concerns, see, still the exam portal is open. If anyone facing the issue, you can try it out. Still 12 minutes time is there. Sunil sir, please go ahead, sir.
Yeah, thank you, ma'am. Good evening, one and all. I am Sunil, working as assistant professor in the Department of CSE, Sri Vishnu Engineering College for Women, Bhimavaram. First of all, I would like to thank for the organizers who organized this excellent faculty development program with all the eminent personalities like Valli Kumari Madam, Arun Balan, and many of the eminent personalities. So on behalf of all our participants, so I would like to convey my thanks to the coordinator, Dr. Prasad Garu, the head of the Department of IT, and the main coordinator, Ramkrishna Raj Garu. Thank you, sir. And the overall coordinator, Uma Devi Madam, thank you for your timely intimation and everything. And I want to convey one thing. Before attending this workshop, I thought cybersecurity is somewhat different and it is away from AI. But after attending this workshop, I came to know the cybersecurity is also part of artificial intelligence. Really, I should thank one and all for giving your valuable insights and sharing your valuable knowledge to all the participants. Thank you, ma'am. Thank you so much for giving this opportunity.
Thank you, sir. Anyone else? Please give your valuable feedback. Chandrasekhar sir. Ramakrishna sir, please give your feedback, sir. Dr. Bomma Ramakrishna sir, please give your feedback, sir. So those who have submitted the assessment, there is a feedback link at the bottom of the page. So please submit that feedback link.
Hello, madam.
Under the assessment tab. Yes, sir. Please go ahead, sir.
Good evening to everybody. This is Vijay Raju, Department of CSC, Swarnandra College of Engineering. Concerned to the FDP, I had many certification courses in the cyber security and privacy. Even though I got a new information from this FDP. This FDP is proved that whatever we learn through our academics is not sufficient compared to this one, because here they have discussed a very new interesting points and the latest cyber attacks and cyber security tips. So this enabled a lot to get a awareness and secure ourselves from the real world threats. So I thank to all the coordinators, especially for the coordinator, our IT HOD sir, for arranging this a wonderful FDP to enlighten the knowledge of cyber security along with the AI, artificial intelligence. Till now, we have used that AI as just our assistant. But this FDP proved that AI is also one of the important tool to understand the security and to secure ourselves and to identify the security vulnerabilities. So I thank to all the people for arranging this wonderful FDP and enlightening the faculty and the participants. And I hope and I also request the coordinator to arrange a more number of FDPs like this one for the improvement of the faculty and all the participants. This will be more helpful. In future, I am expecting more from the coordinator. And I sincerely thank you all the participants and the coordinator. Thank you, madam.
Thank you, sir. Madam, Astra Sarvat, madam, do you want to give any feedback, madam? So those who couldn't submit the test, still the examination portal is going on. You please keep trying for submitting the test. And who submitted the test, provide the feedback. It is under the assessment tab. In ATAL FDP portal, it's mandatory. So after submitting the test, you have to give the feedback link, feedback also. Then only they consider for the participation certification.
Good evening, ma'am.
Good evening, madam.
Myself, Zina Sultana, Assistant Professor in CS Department from Faculty of Engineering and Technology, Khaja Bande Nawaz University, Kalburgi. So I would like to express my sincere gratitude for the opportunity to participate in this FDP on cybersecurity. All the sessions were highly informative as well as well structured and covered the theoretical as well as practical aspect of cybersecurity, ma'am. The only issue we had only with the test, since the site was getting stuck and as other participants were facing a lot of issues, I have faced, I have submitted, but I couldn't see my marks because the site is not working right now, ma'am. Thank you, ma'am, for organizing this FDP. Thank you.
Thank you, ma'am. But still the site is working, ma'am. You keep trying it. You can see your marks too. And after seeing the marks, please submit the feedback also, madam. It is mandatory.
Okay, ma'am. Thank you.
Okay. Thank you, madam.
Sure.
So those who couldn't submit the test, please keep trying. The session is still open. And anyone can give your valuable feedback here. Fanibhushan sir, please give your feedback, sir. So feedback link is provided under the in ATAL FDP portal. So it's under the assessment tab. Yeah, overall feedback form we will share in few minutes, sir. Couple of minutes we'll share it. Meanwhile, you can submit the feedback under ATAL FDP portal, sir. Assessment tab, under assessment tab. Ma'am, you can see the marks, ma'am. You keep trying it. Yeah, due to no overall all over the India, all are submitting now only. That's why this issue is facing. Not only our FDP, like many FDPs who have the schedule the same time, like 6:30 to 7:30. That's why this problem is persisting. But don't worry, keep trying it.
ఎగ్జామ్ రాశారా? ఏంటది? ఏం రాలేదు? లింక్, టెస్ట్ లింక్ అక్కడ సింబల్ లేదా? లోడ్ అవ్వలేదు 5 పేజీ పూర్తిగా.
Narayana sir, your voice is audible.
Anyone else facing any issues? Still exam is not started. Vijayalakshmi madam, please try madam. Still the portal is on, like the exam session is on. So until you start the exam session, it will take time. Because many were able to submit it now. So keep trying it. Feedback is under the assessment tab, sir. In ATAL FDP portal, it's under the assessment tab. Just now we submitted the feedback. Most of them submitted now, sir. You keep trying it. You can submit the test. Almost like 70% were able to submit the test. So those who couldn't submit the test, keep trying it. So most of the majority submitted the test. You keep trying it. We don't know whether they will reschedule the test or not. So whoever didn't submit the test, keep trying and submit it. So both the assessment and feedback, both are important, both are mandatory. Okay. Those who didn't submit the test, still the exam portal is opened. You can check in ATAL FDP portal, still the exam session is open. It was extended. So those who didn't submit the test, please submit it now. Whoever faced issues, now it was resolved and everyone is able to submit the test and feedback also. So keep trying it and submit the test. All the best. The exam test is extended. You try to submit the test now. Okay, thank you everyone. We have shared the feedback link on a WhatsApp group, the overall feedback of this ATAL FDP in the WhatsApp group. This is different from the ATAL FDP portal. So you have to submit the test in the ATAL FDP portal, come feedback in the ATAL FDP portal, and now the feedback link shared in the WhatsApp group is different. So there is no reschedule of examination. So those who couldn't submit the test, please keep on trying it. You can do it. Most of them resolve the issues and they submitted the test and feedback. So everyone, please keep trying those who couldn't submit. We'll end the session now. Thank you, everyone.
Hello, ma'am.